Okay, guys, we're gonna kind of do this in chunks. Try something else out here. So we're gonna talk about applications of the Pythagorean theorem today. So just word problems. So if we're taking a look at this first one here, the bottom of the ladder is 6 feet from the base of the building. I'm gonna start doing a new thing when we talk about word problems. The ladder reaches window 23 feet above the ground. So I'm going to highlight the numbers in here. And what is the approximate length of the ladder? So this is the question that is asking. So this is the kind of information that I have here. I would also encourage you, whenever you see a word problem, to to draw a picture. So we've been working with Pythagorean theorem, so it's all right triangles. So I'm just going to draw a triangle, right? And you can get fancy if you want, and like actually draw the situation. Like I could draw the building, I could draw the ladder. Well, yeah, let's do that. This is the ladder right here. Again, not an artist, so it's not going to be super great. This is the building here. Okay, and this is the ground, right? And I'm just going to put the numbers to it, right? I've already got those highlighted. So the bottom of the ladder, so that'd be right here, is 6 feet from the base of the building. So 6 feet this way. Okay, and the ladder reaches a window 23 feet above the ground. So this is the window right there. Okay, so it's 23 feet this way. So basically, I'm trying to see if this is the right angle right here. I'm trying to find the length of the ladder. So this would be our value for C. Now, if we look at our Pythagorean theorem here, it's a squared plus b squared equals c squared. So it's going to be 6 squared plus 23 squared is equal to that c squared. And then, I'm just going to plug these numbers in here. 6 squared is going to be 36, right? I can also just do it on my handy dandy calculator if I can get it so it's not showing glare. So 6 squared is going to be 36. 23 squared, I don't know off the top of my head, so I definitely want to do that in the calculator. It's 529. We can also do it like this, 23 by 23. I know 3 times 3 is 9, 3 times 2 is 6, add a 0, 2 times 3 is 6, 2 times 2 is 4. I get 9, 6 plus 6 is 12, and I get that to 529, just like that. Okay, so since this is when we're finding the hypotenuse, I know I'm going to be adding these together. They're on the same side of the equal sign, so I just do what it is telling us to do. So it's 36 plus 529 is 565. Is equal to c squared. Now the inverse of squaring something is square rooting it, so it gets rid of those two things and it leaves me with c equals whatever the square root of 565 is. So no, what did I say, 565? Just like that. Hit enter, 23.769. The approximate length of the ladder, I'm just going to round that up to a whole number here, so that'll round up to 24. So 24 feet. The ladder is 24 feet long. I have answered the question just like that, okay? Okay, problem number 2. Again, it's just another word problem. A soccer field is a rectangle 100 meters wide and 130 meters long. The coach asks the players to run from one corner to the other corner diagonally across. What is that distance? I'm also going to circle important words here, wide and long. That tells me kind of like where my numbers are going to go, one corner to the other diagonally. So my soccer field is going to be right here. It literally says rectangle. Okay, so I'm going to draw a rectangle. It says 100 meters wide, so I put that right here. Nope. Let's say, well, actually, that'll be 130 because that's the longer side. That's long. And this is 100 meters wide right there. So one corner to the other diagonally. So here to here, I know diagonally, right? So it's right there. So the idea is we're going to try to find this distance right here. Okay, so I can put this here because it's a rectangle. So now I know this is a right angle because it says it's a rectangle. So I'm trying to find this. So again, this is a hypotenuse problem. Oh, I wonder if these are all hypotenuse problems. Oh, they are. Shoot. Oh, well. Anyway, this is going to be A and B. So it's 100 squared plus 130 squared is equal to c squared right there. Okay, so 100 squared is going to be, if I do 100 times 100, so basically it's going to be a 1 with 4 zeros, so 10,000. And then plus, I'll just do 130 in the calculator. I have so many students out of class. 16,900 is equal to c squared. I add those together, I get to 26,900 is equal to c squared, my square root on both sides. So I'm going to say 16900. Oh, no. Why does this always do this? I'll get one of the blue ones. So 26,900 square root is 164. I just rounded. 164. So what is that distance? The distance is 164 inches. Or not inches, 164 meters. So answer that question, and there you go. All right. Hey guys, I'm trying to like a drawing tablet here to see if this will work for me, and if not, then I'll go back to pen and paper. But anyway, so this is a third problem for the notes. We have a park in the shape of a rectangle. The western side of the park is 6 miles long. It is 10 miles across the diagonal. How long is the south side of the park? Oh, speaking of South Park, right? Maybe that's where that reference came from. I don't know. Anyway, let's see if I can draw the triangle. So let's see. Not the triangle, the rectangle. Well, that's not too bad. Okay. All right, now the western side of the park. Gosh, that's a terrible underline. Okay, anyway, let's just label the rectangle there. So this is the western side of the park. That's 6 miles. The diagonal is 10 miles. Not a super straight line, but not too bad. So 10 miles right there. Then how long is the south side of the park? So we're going to call that as our x. Okay, so we got our rectangle right here. So we are finding this. So we're looking for the leg rather than the hypotenuse right here. So kind of let's pop over here. 6 is going to be my A. Remember, this is A. I don't know, not there. This is maybe more trouble than it's worth, guys. Okay, anyway, let's get it down here. Okay. So A squared plus B squared, ooh, this is terrible, equals C squared. Oof, that's rough. So this is going to be our A, this will be our B, and this will be our C. So I'm just going to plug it in here so I can kind of like get through this. 6 squared, that's not too bad, plus x squared is equal to 10 squared. Okay. 6 squared is going to be 36. 6 times 6, right? So 36 plus x squared, that's the side we're looking for. And that's going to be 10 times 10, which is 100. Oof, man, brutal. Okay, so now this is positive, so we got to do the inverse. So we subtract here, it's going to cancel. We subtract here, and we get to x squared is equal to 100 minus 36 is 64. Whew. Now we're going to square root on both sides. We get x equals 8. Well, and so now how long is the south side of the park? That's going to be 8 miles right here. So let's see if I can write this out right here. The south side is 8 miles. Golly, this is brutal. Long. Ugh, that was awful. All right, guys, there you go. Okay, guys, problem number 4 right here. Alex, oh, look at that, Alex, has a column aquarium with a rectangular base that has a height of 66 inches here. So, yeah, it's 66 inches. Okay, matches right there. A length of 10 and a width of 14.5. What is the longest piece of choya wood? Choya wood, which is a piece of wood that you get for an aquarium that doesn't float, basically, that Alex can buy to fit in his tank. So basically we're trying to find this length here. However, to do that, we need to find the diagonal across the bottom of the base right here. So we need to do 2 sets of the Pythagorean theorem to do this. So we're going to use A here, B here. So it's going to be 10 squared plus 14.5 squared is equal to, we'll call this D, I suppose, for the diagonal. We'll square that. So it's going to be 100, 14.5, 5, nope, not 14.2, 14.5 squared gets us to 210.25 is equal to D squared. So we're going to add these together. So we get 310.25 is equal to D squared, square root, square root. Let's see, 210, so maybe it'll actually pull it in here. I don't know. Okay. Why doesn't it let me do this? There we go. So 310.25. And then we hit enter there, and we get 17.7. So the diagonal there is 17.7 when we round. Yeah, 17.6 inches. Golly, these pens are dying, guys. Okay, so now we have this is 17.6. So that's going to be our A for our new problem. Okay, so 17.6 squared plus 66 squared is equal to C squared. And C is going to be the length of the choya wood, C. We actually know the 17.6 squared is 310.25. So we don't actually have to do that again. We just have to do that 66 squared, which let's do that here. It's going to give us 43.56 equals C squared. Now we'll add those together. 310.25 plus 43.56. See you tomorrow. 4,666.25 is equal to C squared. Square here, square here. And let's see if this will do it. Yeah, there we go. 4,666.25. 4,666.25 is equal to 68. Right there. 0.3, let's say. Okay, so the largest length of choya wood, or largest length of wood, he can buy is 68.3 inches. Got it. Thank you. Let's do the spiral part of this, guys. Let's actually start over here. 3 squared. Is this actually working? It is not. There we go. Okay. So let's start with 3 squared here, just because that we have seen more problems like this. We all know, hopefully at this point, that 3 squared is 3 times 3, which is 9. Okay, another way to think about that is, what's the area of a square with a side length of 3? Okay, 1, 2, 3 here, 1, 2, 3 here. That's a total of 9 different squares in there. So that's what this means, right? 3 squared is, what is the area of a square with a side length of 3? So that's conceptually what it means, right? Now it gets a little weirder when we have negative numbers right here. And I mean, this isn't actually a square, so this is actually not super relevant here. However, 3 to the power of negative 1. I think I showed you guys a problem like this later or earlier in the year. If you have a 3 to the power of 1, that's just 3. Actually, let's structure this differently. 3 to the power of 1 is just 3. 3 squared is 9, like we just figured it out, and 3 times 3 is 9, so that's kind of how it goes up. 3 cubed will be 27, etc., etc. And when you start reducing it, 3 times 0 is actually 1, because you're dividing as you go backwards. When you get to 3 to the negative 1, 1 divided by 3 is just 1/3, which is what we get right here. Now the idea here with this is that this is a fraction, technically. You move this to the bottom of the fraction, and you change this to positive, right? So it's basically 1 over 3 to the power of 1, which is 3, right? So it's 1 over 3, okay? That's the idea. Now, similar right here, this becomes 1 over 3 squared, but we already know this 3 squared is 9, so we can actually change that to 1/9. So that's the idea with that, guys.